So we are going to continue into section 8.6, talking about our formulas, and we're going to focus specifically in this example on conversion between degrees Celsius and degrees Fahrenheit. In the United States, we measure temperature in degrees Fahrenheit. In many other places around the world, and in a lot of science classes, I know myself in a lot of science classes, we measure degrees in Celsius. Right? If we think about it, that's why our freezing point of water, which is 32 degrees Fahrenheit, and our boiling point of water, which is 212 degrees Fahrenheit, are such strange numbers. If we were to use degrees Celsius, our freezing point of water is actually 0 degrees Celsius, and the boiling point of water is actually 100 degrees Celsius. Those numbers make sense, right, for our freezing point and our boiling point. So that's why, again, oftentimes in sciences, we might use and measure our temperature in degrees Celsius rather than in degrees Fahrenheit. Right, as we're going through these problems, we're going to use these two different conversion formulas. These are not formulas that you are expected to memorize at all. These are formulas that you are expected to be able to see and then use based on what you were given and what you were looking for. Right, so in this first formula, we're converting degrees Celsius to Fahrenheit. And so what we're going to be looking for is we're going to be looking for answers in degrees Fahrenheit. And then in this other formula, we're converting Fahrenheit to Celsius, so we would be looking for answers that are in degrees Celsius. So as we're going through these problems and we're picking out the correct formula to use, we want to identify what are we looking for. All right, so let's look at example 2 here, and we'll start with part A. Find the equivalent temperature in either degrees Celsius or Fahrenheit. Right, so we want to find the equivalent temperature. We don't need to use both formulas. We want to figure out which one we want to use. Right, so looking at this, we are looking for our answer in degrees Celsius. So we want to come up here and we want to look for our formula that starts with degrees Celsius. Right, so that's going to be this one right here. So we're going to use C equals 5 times F minus 32 over 9. All right, so now we're going to plug in our 59 degrees Fahrenheit. So C equals 5 times 59 minus 32 over 9. C equals 5 times 59 minus 32 is going to give us 27. Okay. Now we're going to, thinking about order of operations, or thinking about these as fractions, we kind of have a couple of options here. I'm going to go ahead and divide those. 27 divided by 9 gives us 3. Right? 5 times 3 gives us 15. Right? So our final answer, 59 degrees Fahrenheit equals 15 degrees Celsius. Oops. All right, so we plugged in our 59 degrees for our degrees Fahrenheit, and then we work through to get our final answer in degrees Celsius. Again, we don't have to use the other formula as well. We just have to work through each problem using the correct formula. All right, so for example B, now we're looking for our answer to be in degrees Fahrenheit. Okay. So coming up to the top, we want to use our formula that starts with the F. We want our final answer to be in degrees Fahrenheit. So I'm going to copy this formula down here in example B. So we're going to say F equals 9 times C, right? C over 5, and that's where we're going to plug in our temperature in degrees Celsius, plus 32. Right, so we're going to plug in our information from our problem. Right, in our problem, our degrees Celsius is 25. So 9 times 25 over 5 plus 32. Oops. F equals 9 times 25 divided by 5 is 5 plus 32. Using order of operations, we multiply next. 9 times 5 is 45 plus 32. And then finally, we're going to add these. 45 plus 32 gives us 77. So 25 degrees Celsius equals 77 degrees Fahrenheit. Right, so again, as we're working through our temperature conversion problems, right, we want to make sure that we are carefully using our order of operations. We are picking the correct formula. If you happen to end up with a negative result in any of these, right, it is possible to have negative temperatures as well. So don't be surprised as you're going through in your homework if you run into an example or two that do have negative temperatures that are associated with these questions when we're dealing with our Celsius to degrees Fahrenheit conversion.